Sir, audio not audible. Sir, audio not coming.
Durga Prasad garu.
No audio, sir. No audio.
Audio out.
Sairam?
Sir.
Sairam? Audio రాలేదా?
వచ్చింది సార్, మధ్యలోనే వచ్చింది సార్.
ఓకే, ఒక్కసారి మళ్ళీ రిపీట్ చేస్తాను.
సార్ రీప్లే చేయండి సార్.
వస్తుందా? ఆడియో వస్తుందా?
ఎస్ సార్, వచ్చింది సార్.
వస్తుందా?
వస్తుంది సార్. దుర్గా ప్రసాద్ గారు వస్తుందండి.
సార్ షేర్ అవ్వట్లేదు సార్.
సారీ,
స్క్రీన్ షేర్ అవ్వలేదు సార్.
ఓకే సారీ. Hope the AV is very clear and audio is also clear. The starting registration fees is 7,000 and up to 20,000 slots per there. You can register according to your convenience. For first 250 registrations, GST discount is given by ACCA. I request you all to register and participate in NatCon and make the grand section of grand success the NatCon 2024. Coming to today's webinar, Basics in Construction of Bridges by Engineer Suresh Babu Garu covers classification of bridges along with their definitions, major materials and their quality criteria using for bridges, details about pipe culverts, slab culvert, box culverts, causeways, bridges with normal skew and curves, the types of foundations in practice, particularly in bridges. I request our center chairman, Engineer Badam Sundarao Garu, to address the webinar as well the NatCon 2024. Sundarao sir.
చెప్పండి దుర్గా ప్రసాద్ గారు.
Sir, I request to address the webinar as well 2024 NatCon if possible, sir.
Yes, sir, yes,
Or else I will proceed for next.
yes, sir, yes. This NatCon 2024 is very well planned with artificial intelligence as the main topic. It will be highly advantageous to attend that seminar because about more than 16 worldwide famous people are giving their lectures on this artificial intelligence. I request all members of Kakinada Center to take this opportunity to join in this Mumbai seminar. This topic on basics of bridge engineering, which is very essential to know about the basics of bridge engineering, as everybody knows that during last week itself in Bihar, 2 bridges were failed. Why these things are happening? Why previously these things are not there and why recently the failures are increasing? Because lack of knowledge, even basics for the engineers. So our today's guest, Sri Suresh Babu, is a eminent person having excellent knowledge in engineering, and with his lecture, we will learn the basics of bridge engineering. Thank you, Suresh Babu Garu, for immediately accepting our invitation and giving us a chance to introduce you, sir. Thank you very much. Thank you.
Thank you, sir. With your support only, we are organizing these webinars for every month, sir. And now it's my pleasure to introduce Engineer Suresh Babu Garu, Deputy Superintending Engineer, R&D Circle, Nellore, born in the year 1962. He obtained his bachelor's degree in technology from Nagarjuna University with distinction. After his degree, he taught as lecturer in NBKR Institute of Science and Technology from 1983 to 1986. Later on, he joined Roads and Buildings Department as Assistant Executive Engineer in the year 1986 and held various positions. Presently, he working as Deputy Superintending Engineer, R&D Circle, Nellore. His outstanding achievements are constructed 10 plus major bridges, 1 ROB, and written 2 books, Simple Way of Constructing Road Bridges, Concrete for Durable Structures. Now I invite Engineer Suresh Babu Garu to start the lecture. Welcome, sir. Hiram, is PPT visible?
Yes, sir.
Okay. I request Suresh Babu to start the lecture. Saira,
Sir.
could you please help the speaker to start the lecture?
Yes, sir. I'll call him.
Suresh Babu, unmute yourself and start the lecture, sir. Sir, unmute, sir. Please unmute, sir. Sir, please unmute, sir. Suresh Babu, unmute and speak, sir.
Still muted, sir. Still muted condition.
Good morning, Durga Prasad.
Sir, good morning, sir.
I think he is unable to unmute, sir.
Yes, sir. We are calling.
Host can.
సార్ అన్మ్యూట్ చేయండి అవట్లేదు మరి ఇక్కడ మాకు అన్మ్యూట్ సింబల్ చూపించట్లేదండి ఒకసారి లాగిన్ రీలాగిన్ అవ్వండి సార్ ఒకసారి క్లోజ్ చేసి లైన్లోనే ఉంటాను లాగిన్ అవ్వండి సార్ ఒకసారి స్పీకర్ ఆన్ చేసుకోండి
Durga Prasad, can you hear me?
Yes, sir, you are here. Just I called speaker, sir. He has technical problem. He is solving, sir. Just
Okay,
give me a
okay.
minute.
Just I was just thinking whether I am connected or not. Thank you.
Sir. Sir. Open it. Sir, excuse me for the interruption. Give us 2 minutes. The speaker has technical issue. Give us 2 minutes, sir.
Hello, are you able to hear me now?
Yes, sir. Yes, sir.
Yes, sir.
Yes, sir. Audible, sir.
Okay, before
Yes,
I start my discussion,
1 minute, sir.
I would like to thank
1 minute, sir.
Dr.
Please on your video, sir.
Yeah, I have opened my. Okay. Video is also
Yes,
open.
sir. Now okay, sir. Now okay, sir. You can start the presentation, sir. 1 minute.
Before starting my discussion, I thank Engineer Badam Sundarrao Garu, Chairman, ACC Kakinada Chapter, Sri S. Durga Prasad, Secretary, ACCI Kakinada Chapter, Dr. Koka Narasimharao Garu, Professor of JNTU, who encouraged me a lot to deliver this lecture. First of all, I want to clear that I am not going to tell anything extraordinary. Whatever I speak is very simple basics of construction in bridges. So to start with, I prefer to tell you every expert today was once a fresher. I repeat, every expert today was once a fresher. Give freshers one opportunity to grow and become an expert. They are the future builders of the nation. It is the responsibility of senior engineers to train the young engineers and clear their doubts from time to time, duly embracing them with affection. Next thing is, knowledge must be distributed to all the persons who are in need, like prasadam placed before God. It is a divine act. Sharing knowledge is a divine act in my opinion. And finally, intelligence without character is not useful to society. We all must, everyone must inculcate the habits to build character with moral values, principles, ethics. Then only we can see the welfare of the nation and discharge our duties properly. And finally, the life of bridge structure is generally 100 years. If we construct one bridge and joining the department, we shall be retiring from service after 35 years. the structure shall remain for 100 years means even after my demise, the structure shall remain on this world. So that is the greatness of constructing bridges. Okay, now let us go to the subject. So the classification of bridges, we have to see in this slide. Sairam, go to second slide. Mr. Sairam. Okay. Consider you are given a task of formation of a new road. What shall you do first? You just make a reconnaissance survey from here to there, the places which you are supposed to connect. On the way, you find some streams crossing your alignment. So what shall we have to do? We cannot stop the water. They must be allowed to go, pass through and reach their destination. IRC 5, Code of Practice for bridge designs, definitions and terminology is given by IRC 5. Now, we can construct bridges across streams. Streams may be a field channel or a field canal, a canal of a river or a BABU or a river. So these are the structure, these are the streams generally we need to cross while forming a road. Sometimes we come across with triangular lines. So what do we do? Generally, we provide level crossings where the road traffic and rail traffic will be at the same level. And whenever the train comes, the road traffic shall be stopped. And after going the train, the road traffic shall be allowed. So in order to mitigate this problem of waiting, we construct bridge across a railway line. Another thing is, we need to construct some bridges to cross traffic junctions. And finally, the latest form of this road bridge constructions are traffic interchanges. Traffic interchange means grade separated traffic intersection. So if we are crossing two highways, we can provide a highway, but the vehicle coming on the upper side cannot enter the road in the lower side unless you provide some access from higher level to lower level in the form of a circle. So that is called interchange. Now let us see what are the various types of road structures that are constructed across streams. If the stream is very small, a field channel for agriculture, you can construct culverts. If the stream is a bit big, or you can say a BABU is there, when we don't have money, we'll just leave it and we construct a causeway there. If we have adequate money, we'll construct a bridge, a high-level bridge. Again, under culverts, we can classify them into pipe culverts and slab culverts. The discharge through pipe culverts is very low and may be limited to small channels carrying water for irrigation purpose. Slab culverts are a bit larger ones compared to pipe culverts, and they can take more discharge and the height can be increased to the extent you require. In case of pipe culverts, the height is limited to 1.2 or 1.5 meters above the sea level or the existing ground level. When the depth of flow is more than 1.5 meters, say 5 meters is there, we cannot go for a pipe culvert. Invariably, we must go for a slab culvert with a length of 2 meters and the height may be as required, maybe up to 5 meters or 6 meters. Next, we go for causeways. Causeways are basically meant to pass the ordinary flood level discharge through the vents. Generally, we have the variations in flood levels. We have more flood level in rainy season, a little less in winter season, far less in dry season. The causes are generally designed to take a discharge of 1/3 of the total discharge in MFL condition. If you have a discharge of 100 cubic meters per second, the causeway vents shall be designed to take a discharge of 33 cubic meters per second, and the balance 67 cubic meters per second shall be allowed to pass over the causeway. So here the problem comes, when water flows over a causeway, we have a problem of the vehicles being washed away due to water pressure. So you have to know to which depth of water we can allow the vehicles over a causeway. It is very important that a depth of water of 0.3 meters above the causeway can wash away the cars during high floods. I repeat it once again, when the depth of water flowing above the causeway is 0.30 meters, a car crossing the causeway can be washed away. We are not supposed to allow the cars when the depth of water is 0.2 meters or more. Every year, large number of persons traveling in car in self-driving mode venture into the floodwaters over the causeway and are getting washed away. So this must be given more publicity for each and every car driver not to venture into floodwaters when the depth of water flowing over the causeway is 0.30 meters. It is the responsibility of the department to erect a signboard duly informing the public that cars with the water above the carriageway is fine. I have never seen such a caution board anywhere in any road in the entire state. It is very important and needs to be erected. Next, come to bridges. So bridges stopped at any time in their lifetime of 100 years. So what do? You calculate the MFL for the past 100 years, available records available with the irrigation department. We consider that MFL and we add
సార్ స్లైడ్ చేంజ్ చేయాలా?
You go to the slide number 11. Slide number 11, I want to.
This one, sir?
It is not seen now. I'm just opening in my cell phone.
Voice is not audible, sir.
ఏం అవ్వట్లేదు.
It is not audible.
Yes, sir. Yes, sir. Yes.
Please.
సార్ సురేష్ బాబు గారు మీది వాయిస్ రావట్లేదు సార్, అన్మ్యూట్ చేస్తారా? సురేష్ బాబు గారు ఫోన్ కూడా స్విచ్ ఆఫ్ వస్తుంది సార్, మీది ఫోన్ స్విచ్ ఆఫ్ వస్తుంది. ఫోన్ అన్న ఆన్ చేయండి సార్ ఒకసారి. ఫోన్ ఆన్ చేయండి సార్, ఫోన్ ఆన్ చేయండి, కాల్ చేస్తున్నాను. సురేష్ బాబు గారు ఫోన్ ఆన్ చేయరు ఒకసారి.
సార్ సిస్టమ్ అన్మ్యూట్ చేస్తే సరిపోతుంది సార్. సిస్టమ్ ని అన్మ్యూట్ చేయడానికి ట్రై చేయండి సార్.
సార్ అన్మ్యూట్ చేయరా?
Now am I audible to you?
Yes, sir. Yes,
Okay.
sir.
Okay, I am operating from phone. So the general rule for providing body wall for pipe through body is you have to provide 2H on either side of the vent. H means the sill level, the level difference between the sill level and RCL means road crest level. It is on the assumption that the streamer channel that is taking the water will have a side slope of 2:1. When MFL condition is reached, it is expected that the channel will be fully flooded. In such a case, we need to provide body walls to that length or to the width of the cross section at MFL condition. So that is the simplest way. The foundations need not be taken to much larger depth. You can take up to a depth of 0.90 meters with bed protection. Even without bed protection also, we do not have much cover in case of pipe culverts. The limitation of pipe culverts is mainly the discharge and the height. We cannot place one pipe over the another pipe. Just means you can provide one horizontal set of pipes of 1.2 meters diameter. And the discharge is more, we may need to have more height. In such cases, we will go for slab culverts. Okay, next slide, please. Slide of slab culvert number 13. Next. Yeah. This is a cross section of slab culvert. We will have two abutments for single span. We can have multi spans also. So what is the difference between minor bridge and major bridge? I have forgotten to tell you. A minor bridge is defined as a structure having a total length of 6.0 meters between inner faces of dirt walls. So for the time being, consider it as total length, as some of you are not aware of what is dirt wall, what is backing wall, and what is abutment. I will tell you later. For the time being, we can consider a minor bridge is a structure having a total length of 6 meters. So then what is that is the difference between culvert and bridge is that a structure is called a culvert when the length of the slab or vents is equal to or less than 6 meters is called a culvert. From 6.1 meters to 60.0 meters, it is called as minor bridge. And the length of the bridge is more than 60.10 meters and above, it is called a major bridge. So generally, in order to minimize the process of design calculations, ISA SP13 has given you standard drawing, standard section or abutments depending on the height from sea level to arch sea level. So go to the next slide, please. Sairam, go to next slide. Hello.
Yes, sir. This one, sir. Next.
Now go to next slide, please. I'll tell you the numbers. Number 13, this one. This is the extract of the IRC SP13. In this one, you will be given directly. Go to the previous slide, please. Once go to the previous slide. Okay, this is the details of reinforcement. You will be given clear span in the first vertical column. Then next overall length. Next. So all the sections are directly given in the IRC SP13. Type of bars, bottom bars, cranked bars, and straight bars, and everything are given. And you just adapt those sections and the reinforcement in the superstructure, that is slab. Now let us go to the foundation. Next one, please. Now 16. 16. Yeah, this is the section of a causeway, vented causeway. In this case, the main thing, slides are moving up and down. The main thing here is, as the structure is supposed to overtop during high flood levels, there is a tendency for the superstructure to be washed away due to horizontal acceleration of water and due to buoyancy effect also. In order to stop lifting up the superstructure, we provide some anchoring arrangement between the substructure and superstructure. That will be in the form of some hooks or some rods placed in the pier cap and taken into superstructure, that is slab. So that is the only thing we have to provide in causeways, unlike our bridges. Now go to slide number 20, please. Slide number 20, please. Come down, come down. Marking up. Go up. Go up, please.
Slide number 20, sir.
Now go for marking. Different numbers are changing, it seems.
Okay.
I will give you I'll tell you about the marking of bridge. Go to up. Marking of bridge, normal bridge, square bridge, and curved bridge.
Okay, that's okay, sir. This one. Yes, sir. This one, sir.
This is foundation. Okay, this is the one. Okay. So you are given a drawing, duly giving the bearings of the survey lines, and you are asked to construct a bridge across a stream. What we do first, to mark the center line of the bridge, shown as dark circles, are supports. The slopes on either side shown as slopes of the stream. We place the abutment over the bund, and we place the piers inside the stream. So first we mark this center line and the center support locations: abutment, pier 1, pier 2, pier 3, and abutment pier 2. So after fixing these posts or the center lines, we have to provide support pedestals in two sets. We will provide a pedestal abutment A1 from bottom side at a distance of 25 meters from the abutment location. Similarly, we provide pedestal at each support location, pier or abutment at 25 meters distance. And another second set of pedestals shall be provided at a distance of 20 meters from the previous pedestals. Why do you need these pedestals? Once you start excavation within the alignment of bridge structure, you don't have any pedestals at the center. So in order to fix these points after excavation, we need some pedestals, reference pedestals, both on left side and right side. In case if the pedestal of 25 meter distance is disturbed due to movement of heavy vehicles or excavators, we will use the second set of pedestals. We will keep this airlet here on right side and focus it to the extreme pedestal on the left side. And from then we can calculate the distance of 45 meters and fix the pedestal in the excavated area. This is very simple. The pedestals will be kept perpendicular to the alignment. Next slide. Marking for a skew bridge. Okay. This is a typical case when your alignment is going in a vertical direction as seen here, but the stream do not flow in perpendicular direction to your alignment. So this is called skew crossing. Many people can get confused what is the definition of skew angle. skew angle is defined as the angle between the line drawn perpendicular to the alignment and direction of flow. Here you can see a small skew angle of say 10 degrees or something. Some people mistakenly say it is 80 degrees skew, which is incorrect. I repeat it once again. A skew angle is defined as the angle between the line drawn perpendicular to the alignment and the direction of flow. That is called skew angle, but not the angle between the direction of flow and the center of the alignment. So you must be careful in calculating the skew angle this way. So in this case, the support system piers or abutments shall be kept parallel to the direction of flow to reduce the earth pressure on piers or abutments. What happens if you provide your support system, say wall type pier or something like that in perpendicular direction? Water will hit the pier and induce some more additional stresses, which is not taken into consideration in design. So in this case, we provide the support system of piers or abutments of the bridge in a direction parallel to the direction of flow. So in order to have the support system, it may be a single circular pier or set of 3 circular columns called trestle, or wall type pier, just wall type pier. It will be like a wall and with semicircular cutwaters. Here we have to, after fixing the center line, you have to fix the 90 degrees angle to the pier at that point and turn your third light to skew angle as calculated earlier, and fix the pedestals on left side first, and you transit the third light and fix the other 2 pedestals on right side. I repeat it once again. You place your third light at pier 1 location and align it to the alignment of the bridge and turn it to 90 degrees. That will give the line normal to the alignment of the bridge. Now you rotate the third light by skew angle, fix it. There, in that direction, you can fix 2 pedestals on left side and transit your third light, and you can fix other 2 pedestals in the other direction. So you have to remember this specifically, the skew angle definition and how the pedestals are constructed. Now let us go to the marking of bridge for curved bridge. Sometimes it may be necessary for us to have curves, especially in village limits, in the construction of road over bridges or road under bridges. Due to the constraint of land or government land available, we'll adapt some curves in the bridge itself. In this case, in which direction we are supposed to keep the support system? Okay, I will tell you. We provide the support system. The support system may be a pier, single circular pier, or 3 columns, trestle, or wall type pier. We have to provide this support pier 1 in radial direction at that particular point. How do you get the radial direction at a particular point? You have to go to surveying. There we will be given some calculations, and we calculate first the line of tangent, and from that we calculate the radial direction by turning the third light by 90 degrees. So if you observe the line of pedestals, you can see the inner edge or inner pedestals are having less span lengths, whereas the outer pedestals have more span lengths. Your superstructure shall also be in the same fashion. You will be having smaller length on the inner side and you will be having larger length on the outer side of the circular superstructure. It may be a deck slab or a T-beam or something like that. So which length we have to take? We have to take the length of P1 and P2 measured in straight direction. We ignore it as the curve. We consider P1 and P2 as a straight line. We take this center to center effective span in this line, duly detecting the supports. You will get the clear span, and from center to center of the bearings, we will have the effective span. So here you have to remember that the support system abutment or pier in substructure must be positioned in such a way that they shall be in the radial direction. They must be in the radial direction, but not in any direction as we like. The radial direction shall be calculated after calculating the tangent length, tangent or angle, and we with on the theoretically by 90 degrees, that gives you the radial direction. There we can provide the substructure. So the inner side of the superstructure shall be less and outer side of the superstructure shall be more. But the design effective span shall be taken at the center as shown with arrow. Go to next slide, please. Okay, now let us discuss about the foundation. So, what is the minimum depth of foundation that is supposed to be provided for road bridges or road culverts? The minimum depth of foundation shall be 2.0 meters below the sea level for any culvert or for any bridge. Generally, the foundation depth is decided by the maximum scour depth calculations. And that comes, we have to go to irrigation engineering something, we have to calculate the discharge. From that discharge, we will calculate the maximum scour, and then to that we will add 1/3 grip length. There we fix the foundation level. Generally, it is all taken care of by design engineers. So when do you call it as an open foundation, or when do you call it as a deep foundation? Or you can say shallow foundation or deep foundation. And the depth of foundation is less than 4.0 meters, it is called shallow foundation. And the depth of foundation is more than 4 meters, it is called as deep foundation. What are the classifications in shallow foundations? It may be a raft foundation. It may be isolated individual footing. What are the classifications in deep foundations? It may be a well foundation, or it may be a pile foundation. So when do you go for deep foundations? And the depth of scour in a particular location of a structure is more than 4 meters, as it is not possible to excavate beyond 4 meters. We provide well foundations or pile foundations. I will explain it later. When we have good soils with SBC of more than 30 tons per square meter available at shallow depths, or sometimes you can take 20 tons per meter square also. In case of ROBs or RUBs, we do not have any scour as there is no water flowing. In such cases, we need not consider the scour depth calculations. We fix the foundation level depending on the foundation soil available. If we have good foundation soil available at surface itself, generally in Rayalaseema, we do have rock at surface level itself. So does it mean can we base the foundation at surface level itself? The answer is no. There is a code IRC 78 guidelines for the foundations and substructure of bridges clearly mentions that the foundation shall be taken to a depth of 1.50 meters when soft rock is met with and must be taken into to a depth of 0.60 meters when hard rock is met with. So that is the minimum depth of embedment in rocks. If we have a good hard rock available at the bed level itself, we are not supposed to place our bridge foundation at surface level because there is a possibility of sliding of foundation over hard rock. So don't you have sliding at 0.60 meters below the bed level? There also we do have sliding. So how to mitigate this problem? We provide anchorage arrangements under the footing. We insert or we bore some holes into the rock at smaller spacing, not specified clearly, say 0.5 meters spacing. The diameter of the rods may be 25 mm dia. 0.5 meter may be taken into the rock. 0.5 meter may be taken placed above the rock. After placing this reinforcement or anchorage arrangement, or you can say keys, we lay the footing over the rock as usual and construct our substructure and then superstructure. When the depth of when the scour depth is too high, we will go for well foundations. Well foundations are a bit costlier compared to shallow foundations. And in compared to well foundations, file foundations are some more costly. Generally, as on day, the running meter rate for the cost per running meter of a bridge with shallow foundation shall be 7.00 lakhs per running meter. If you go for well foundations, depending on the scour depth calculations, the cost of the bridge per running meter comes to 12 lakhs per running meter. If you provide pile foundations, you have to incur an expenditure of 14 lakhs per running meter of the bridge. So, for example, if you take a bridge of length 100 meters, if you adapt shallow foundations depending on the type of the foundation soil, it works out to 7 crores. If you don't have hard soil at shallow depths and you must go to lower depth depending on the scour and all those things, if we adapt a well foundation bridge, it costs 12 crores. 100 meters bridge into 12.00 lakhs cost 12 crores. If we adapt pile foundations, it may cost around 15.00 crores. These figures are purely rough and varies from time to time, year to year, including the cost of approaches. For obtaining the administrative sanction, temporarily we have to ask amount the government. We adopt these values for obtaining the administrative sanction from government. After receiving the administrative sanction, we conduct trial bores and decide the type of foundations and design it and calculate or prepare the DPR as per the designs. Okay. Now let us go to the next slide of sandy. Okay, I will tell you the bridge components. Bridge components we can divide into 3 categories. The first one is foundation. Second one is substructure. And the third one is superstructure. Foundation is a structure that is placed below the ground level to take the loads coming from the superstructure and substructure. The foundations are designed in such a way that the total load shall be distributed and the maximum pressure due to the slave loads and dead loads shall not exceed the SBC of foundation soil. I repeat it, the maximum pressure on foundation soil shall not exceed the SBC of the foundation soil, otherwise the structure will be unsafe. Or you may have to increase the area of contact so that the pressure, the maximum pressure on foundation shall be less. Above ground level, then we will construct one support system we can call substructure. Substructure may be defined as a structure between the foundation and superstructure. It transfers the load coming from the superstructure to the foundations. So there may be abutments which take both earth pressure and vertical live load. There may be piers which take only vertical loads. So in these abutments, we can have circular piers. In piers, circular piers. Abutment will be a wall type, or nowadays we are providing RS wall to take the earth pressure and a pier to take the live loads from superstructure. So above we have seen some inclined lines in the substructure. You see it, what for they are provided. The embankment shall be abutting the abutment, and any water that is coming from top shall be drained off. If it is not drained off, it induces hydrostatic pressure. Sometimes it will be more than the earth pressure. So to reduce or to minimize or bring it to zero, we provide say drainage system called weep hole system. You can see the weep hole on the left side is on higher level, on right side it is on lower level, so that it drain off the waters with the help of a filter media placed behind the abutment. Above that, we have one L-shaped structure. The bottom one is called bed block, and the vertical member is called backing wall. So over this bed block, we have a small box that is called bearing pedestal. For this bearing pedestal, we place our bearings, and we rest our bearings over this. We rest our superstructure over these bearings. So what is the purpose of bearings? The purpose of bearings is not to transmit any horizontal earth pressure to the substructure. The bearing shall take some deformation when the superstructure expands or contracts, does not allow any horizontal thrust to the substructure. Next. Go to next slide, please. Yeah, this is a photo that is taken the construction of road overbridge at Chirala, where we do have totally sandy soils. We cannot excavate trenches in sandy soils in different sections, L into B, like that. In such cases, what we do is we excavate a canal to the total length of the bridge. You see the canal that was excavated throughout the length of the bridge. So go for next slide. Here you can see on the left side, we provide some shutters or support system to prevent failure of the earth. The building on left side is the railway quarter. They didn't allow us to give their building to us, and were forced to execute this excavation adjoining the railway quarter for providing shoring and shuttering. So after placing the shoring and shuttering supporting soil, we excavated the required footing sections filled with water here. Next slide, please. Go to next slide. Now you can see back one slide. Here you can see a canal was excavated continuously throughout the length of the bridge in a location where our footings are supposed to be placed. There we have laid bed concrete. In M15 or in olden days it was VCC 136. Over that we place the reinforcement of foundation And here the substructure is 3-column member trestle. You can call as 3 piers with 1 foundation and 1 supporting beam will be there at the bottom. Next slide. Yeah, this is a clearly visible to you how the reinforcement shall be constructed for footing of a open foundation in sandy soil. Still, the earth is not filled. We just place the shutters. The reinforcement seen at the level of shutters is the footing reinforcement. Above that, we have a connecting between the 3 circular piers. That is called connecting beam. It takes care of the punching shear and everything. And the 3 columns support the superstructure. Next slide. Next slide. Yeah, this is another view of your reinforcement in the footing of a pier. We have 2 layers of steel in the footing. We have 2 layers of steel in the footing, and we position the columns or piers at the design or desired locations without any violation or without any variation. So this way we will provide the footing and we will provide the reinforcement of footing. Then we lay the concrete as usual. After that we lay the connecting beam. After that we will pour the concrete for piers. Next slide please. We can show the piers in that one. Next slide please. It is the somebody is talking, please mute him. Hey Mirial Goda. Hey Mirial Goda, please mute. Now this is the concrete being laid for abutment. In abutment, we need not provide any steel. It is a plain concrete member. And it will be laid in thinner layers of 200 mm and compacted and as per the section design given by the design suite. Next one. Next one, please. Yeah, now you can see the foundation on the left side, a connecting beam, 1 foot or 0.4 meters above the footing, and the shutters for piers. So once the foundation is completed, we place the shutters here and pour the concrete to a height of 2.5 meters each lift. Each lift is generally taken as 2.5 meters depending on the height of the piers. Next one, please. So now you can see the circular piers, footing at the bottom, connecting beam, and circular piers, first lift laid. First lift means they are laid for 2.50 meters only, and the reinforcement shall be extended. Here, what we have to remember is, unlike in buildings, we cannot keep all the slabs at one length, at one point. In buildings, we provide all the slabs for the top of our first floor, the ground floor slab. In this case, we have to stagger or we have to plan the reinforcement in such a way that not more than 1/3 of the steel shall have slabs at any point. Unlike in buildings, we cannot keep all the overlaps at one point. So some rods will be meeting at here. The difference between these two labs must be 2.50 meters. Minimum difference between labs must be 2.50 meters. Okay, next slide. Next slide, please. Okay, with this I conclude the presentation as we already reached the time of 12:30. This is all about the open foundations and bridges with open foundations. So we can discuss it later whenever we get some time about the well foundations and bridges. Now you can ask your questions. Interaction session now. Okay, anyone who wants to ask questions, you can ask now. Or if you have anything in chat box, I will see here. Okay. You can ask questions now. Are there any questions in chat box, dear sir?
Sir,
I
we are
ask something?
discussing the share first group, sir.
Hello? Can you
Okay,
hear
yes.
me?
Okay. I am able to hear you.
Uh,
We'll
Can you
discuss
What is your doubt?
give us some idea about how the superstructure was placed on the piers?
Please repeat your question.
Can you show us a slide about the superstructure construction? The deck, the
Yeah,
bridge deck.
superstructure is generally designed in a standard way by Ministry of Road Transport and Highways.
No,
We
I'm
have
not
standard
talking about
drawings.
design. How it was built.
Yeah, we have to go to another slide somewhere. The time is not permitting me now. Some time was last 15 minutes or last. So I can tell you what are the type of the superstructures. The superstructure may be an RCC deck slab. It may be RCC T-beam superstructure. It may be widened deck slab with hollow sections. It may be a box girder with hollow sections. It may be a segmental box girder. These are the general types of superstructures adopted in construction of bridges. In our departments, the span arrangements from 0 to 10 meters, we construct RCC deck slab. And the span arrangement is more than 10.1 meters to 25.0 meters, we adopt RCC T-beam superstructure. When it is more than 25 meters, we go for box girder or segmental box girder, whatever is possible. So these are the three types. Wired deck slab is also one type of superstructure that is economical for spans up to 20 meters only. So when the span is more than 25.0 meters, we'll go for box girder of 30 meters. We can go even more. We'll have casting cycle in our departments. We will be given the reinforcement drawing in detail by the Ministry of Road Transport and Highways. And the quantity is also given. You just check the drawing and place the reinforcement, pour the concrete as usual, compact it, cure it. It is as you do for your footings. Nothing more than that. The support system has been checked carefully for superstructure. It is preferred to provide steel clips, not the Kakinada pulleys as you adopt in buildings. Okay. Any more questions?
Sir, one question in chat box, sir.
Tell me.
Whether
Please
Cajuns,
read.
whether
Kaizens.
Cajuns are called well foundations?
Kaizen is not well foundation. Well, it is a support system surrounding the well foundation that does not allow water to flow into the well foundation while laying concrete. We provide Kaizens. They do not take any load. They are protective work to the well foundation and load shall be taken by the well foundation only. It prevents ingress of water from outside to inside of the foundation. Next. Any more questions, please?
Yeah, I have to ask. Can I ask something?
Okay.
What are the generally the grades of concrete that you use for reinforced concrete bridges?
Generally, it depends on the exposure condition. It is given clearly in IS 456. The minimum grade of concrete is in plain concrete is M15. In RCC, it is M20 when the atmospheric condition is not critical. In case of areas nearer to sea coast, within a distance of 25 kilometers from sea coast, we provide RCC with M25 grade concrete. The minimum grade of RCC for structures nearer to sea coast within 25 kilometers shall be M25 grade concrete.
I don't agree with you there, sir.
Okay,
Your
discuss it.
severe.
Discuss it.
If you are having a severe exposure condition, the minimum grade of concrete should be M30.
Yeah, severe, very severe or severe condition shall be taken if structures constructed along the sea coast. I am telling you that the structures constructed near
Even up to 20 kilometers from the coast, it has to be considered as severe.
okay, we can take M30. Why not M35? You can go for M35 also.
M35 also. See what the grade, what the code specifies is the minimum grade. You can always go
Minimum
higher.
grade is, to the best of my knowledge, whatever I say is to the best of my knowledge only, is M25 offshore. Shore. It is M30 for the structures adjoining to sea coast. To the best of my knowledge, if there is any variation, that will be taken care of by design engineers. That is not the responsibility of construction engineers. Right?
Yeah, naturally.
Anybody?
Yes, sir. One question is posted by Akhil Reddy. How much
Yes.
diameter reinforcement is provided in the pile foundation?
No, that shall be designed. We cannot say this much like this diameter shall be placed or this diameter shall be not be placed like that. Generally, the piles provided are end-bearing piles in bridges. In buildings, we provide piles with skin friction. In bridges, we don't consider the skin friction of surrounding the pile, and we rest the pile over a rock. We will provide set of piles, maybe 4, are all connected by one pile cap for supporting one PF. There is no such criteria. Minimum is 20 m. Generally, we adapt. There is no such guidelines. What is the minimum length and what is the minimum diameter and maximum diameter in pile foundation? Generally, we go 20 m and above. Okay.
Sir, in your presentation, one slide is skipped, sir. That is quality of material, sir. Quality of
Yeah,
materials.
as we are running short of time, I skipped it.
Yes, sir. Could you please tell about this water, sir? Main.
Yeah.
Yes, sir.
Water used for cycle concrete shall have a pH value of more than 6. This parameter is not generally looked into seriously by the construction engineers. In case of bridges over rivers, we get good water with pH value more than 6. But in case of ROVs in town limits or in some places where groundwater is hard and pH value is less than 6, we are not supposed to adapt or to use the groundwater at any cost. We have to provide extra lead for bringing the water fit for construction of structures. Generally, potable water is considered as fit for construction of structures and they will have a pH more than 6. We have to check the sulfate content in water also. That must be less than 400 mg per liter. Similarly, for RCC, chloride content shall also be checked. It must be 250 mg, must be less than 250 mg per liter for the RCC. It may be around 1000 mg per liter in plain concrete. These are the 3 important parameters that are to be considered that must be looked into the water. That is generally neglected. We purchase a pH meter in the form of a small pen and you can verify the pH at site by yourself itself. We need not send sample to the laboratory. Purchase a pen, page pen costing around 600 rupees, available in Amazon website. Keep it in your pockets, test it yourself, and see whether pH value is more than 6 or less. When it is less than 6, simply reject it. Ask the contractor to bring potable water from the nearby overhead reservoir tank, water supplying to the municipality. For that, we have to pay extra amount. Even though if you pay extra amount, that is more useful in the service life of the structure. Most of the structures, buildings especially, are collapsing in a short span of 20 years. Why? Because of little cover or no cover. 2, uses of hard water. Earlier, in the past 20 years back or so, we are not having this much awareness about water. The water, groundwater available at site shall be directly used in concrete mixing, curing, and etc. So the strength of the concrete is drastically reduced if you use water with sulfate content more. Or if chloride content is more, it may induce corrosion in reinforcement. Most of the buildings constructed by government departments, I repeat, most of the buildings constructed by the government departments, maybe Police Housing Corporation, Social Welfare Corporation. Police Housing Corporation constructs quarters for police officers. Social Welfare Department constructs buildings for hostels and schools. All the buildings are now in dilapidated conditions and are reconstructed with huge amount because of 2 missing elements. One is no cover or little cover. 2, uses of hard water having a value of pH less than 6. Okay, you must be careful. Regarding steel, what are the parameters we have to check? First, we have to check the characteristic yield strength Fy. Okay, we are adapting HOSD bars, or you can say TMT bars. It must be more than 415 Newton per mm square. Is it sufficient? If we get required yield strength, can we accept this steel? Do you have any other parameters to be looked into? Even in buildings also, you have to look at the second parameter. All of you are mostly bridge consultants. What is the second parameter? We consider the steel suitable for construction. It is percentage elongation. Percentage elongation is another important parameter in addition to the characteristic yield strength of the steel. It shall be more than 14.5%. Why? Building steel shall have minimum percentage elongation. What happens if you don't have, if you have 0% elongation? The answer is like this. In extremely adverse conditions like earthquakes, there will be stresses induced alarmingly high than the design values. In such cases, the steel fails, or concrete also fails, no problem. If it suddenly cracks without giving any warning, all the inmates of that building shall die. You got my point? If you have 0% elongation, and when you have stresses induced in the steel more than the design stress, the steel breaks into pieces and collapses immediately without any warning. If you have some time for evacuating the people, you can save the human lives. For that purpose, we provide this percentage elongation. On receiving alarmingly high stresses, the steel shall not break into pieces. It bends or it elongates to 14.5%. It takes some time to reach to breaking point. During that time, we can evacuate the people inside the building and save the human lives. So in that aspect, percentage elongation is essentially to be looked into. Another thing, while bending, the steel should not be broken. So there also we have to know the percentage elongation or the behavior of the steel when it is bent or something like that. Cement, you know everything. Everybody knows. So I ask you one question, why not we go for 63 grade cement? I'm asking you one question. Now we are adapting 53 grade cement. Previously we were having 43 grades. Prior to that we were having 33 grades. Now I ask you, why not we go for 63 grade cement? Okay, I will ask you in an indirect way. Which grade of cement out of 43 grade or 53 grade is more convenient for construction?
43, sir.
Yeah, but the manufacturers are not manufacturing 43 grade cement in any company in the entire India. Why? Because they create a picture in the minds of the public that 53 grade cement is more convenient for construction and it lasts for more years. That information is created in the people who construct the buildings. But actually 53 grade is detrimental to the structures. The heat of hydration while using 53 grade cement is very high compared to this cement of 43 grade cement. The problem in the department is because I am from department, I speak about department only. I don't know whether the private persons are doing in a better way or not. Today we lay the concrete. So up to 10 o'clock or 11 o'clock we lay the concrete. Tomorrow all the masons, workers, engineers and myself take rest at home. Nobody goes to the site and pour water. No water shall be available to concrete for curing on the second day. On third day, the mason comes in a laser way at 10 a.m. and starts constructing small dikes for ponding of water. In order to harden these dikes, we don't allow water ponding on third day also. The concrete is starved of water for 36 hours after it is laid. The requirement of water is more in the first 12 hours or 12 to 24 hours, 24 to 36 hours. But we are not giving water. We are starving the concrete without water for 36 hours. Even if we give more water, we will not get the required strength. It is a common problem in the department. So then I may ask, what shall to lay the concrete in dry condition. Next.
One question, sir. In slab culverts,
Yes.
the slab should simply rest on backing wall.
No, backing wall will not take the slab. The slab shall be resting on bed block. Horizontal member is called bed block. We will rest our slab when the span is less than 10 meters. We provide what is it called? Craft paper as bearing. So the horizontal member will take the load of the superstructure of deck slab.
He is asking about approach slab, sir. Approach slab.
Approach slab should rest on the backing wall on one side, and the other side is free. There is a problem with approach slab. Generally, they settle on free end due to settlement of the filling under the approach slab. IRC 78 says provide gravel filling behind abutment and under the approach slab. Gravel is a different word that is used in the code. The gravel which we are using is just redder. It will be having more plasticity index value more than 6, even liquid limit more than 25, and it is not suitable for filling behind abutment or under the approach slab. Gravel means the gravel that is available somewhere in nearer to Singarakonda, where the NH authorities laid one CC payment for landing of warplanes. There the soil cut vertically do not slip. That is a correct word of gravel. That is the correct gravel. The gravel which we are calling and which we are using is red earth. We should not fill it with this red earth. Instead of that, you can fill it with stone dust in thin layers of 100 mm by 100 mm, or with sand also you can fill. The problem with filling of sand under the approach slab is that there is a possibility of sand being taken away by water through weep holes in the wing walls. So to avoid the taking away of the sand through pore water through weep holes in the wings, we provide a filtration filter. Inverted filter will be provided, in which the smaller stones will be on earth face and larger stones will be on wing wall face. Abutting that, we will provide some gravel filling also. This gravel prevents the passing of sand particles through water, and water will be dissipated through the filter media into the weep holes in the wing walls and drained into the river stream, into the waters of stream. So you got it now?
Yes,
Any
sir.
doubt?
Nowadays, we are placing this geotextile between interface of fill material and this filter media, sir.
Yeah, we can go for it, but small in a small project of say 10 crores, we cannot bring the geotextile material and use it. You can filter, you can use geofilter or geotextile for filtering the loss of fill material.
Hello, sir.
Sir, one question
Okay.
from Rajshekar, sir. Any
Okay.
anchorage to be done between the backing wall steel and approach slab?
No, they should be independent. There shall not be any connection between the backing wall and approach slab. It simply rests on the backing wall. Okay. Dr.
Hello, sir.
Narasimha Garu is asking something.
Yes, sir. A very nice presentation, sir, and
Yes.
elaborate presentation too.
Okay.
Yeah, at the outset, I would like to congratulate you for accepting our invitation to present your valuable suggestions and the valuable presentation regarding the bridge engineering. My father used to say, a civil engineer is a great engineer when he becomes a good bridge engineer. During my graduation days, he used to say these words, sir. I always remember whenever you are posting some posts in the share group, post group, and other groups, I always remember these words, sir. And
See,
one more
in
thing.
return, I say I'm thankful to you for your encouragement and for giving me this opportunity to deliver a lecture from ACC Kakinada chapter who are not known to me.
No, sir, not at all. It's a good pleasure to us, sir, on behalf of PCA Kakinada Center. And I have some issues to share with you, sir, regarding the bridge engineering part of issues are considered.
Okay.
Regarding this, stalwarts like you in the bridge engineering has to have the representation to the IRC regarding the publication of the what we call the most standard drawings for the revised code of IRC 112. It's
Yes.
too delayed to have the publication from the IRC part of that, sir.
Yes.
And last time we have some discussion, the shear force group also regarding this issue. As per my knowledge, in 2019, MOST has invited from the private consultants regarding the publishing of these standard drawings, but that is not yet finalized. I request you to have some sort of pressure on the IRC to publish these most standard drawings for the bridges based upon the new code of IRC 112. That is the very urgent need of the hour, sir.
Definitely, sir. We, on behalf of the department, will write a letter to IRC to MOT to publish the drawings based on limited method. That will be more economical.
Yes, sir.
Definitely, we have to follow it. But in government departments, people are not so energetic or lethargic, you can say. Activism is also one problem. It takes months for the file to come from one side to another side. Anyhow, I will try my best to convey this message to our HOD.
One more thing, sir, regarding the IRC part is considered. In the IS 456, we have the special publication like SP16. When coming to the IRC bridge codes and all that, there is no special publication like in terms of the design aids. There are special publications like SP13 is there. We are calling for the small bridges and the culverts for the design based upon that. From the hydraulics point of view, that is okay, sir. But it requires some sort of detailed explanation, especially for the budding engineers and all that. It requires a detailed design aids for the bridge designs part also, like superstructural designs and also for the substructural designs with detailed calculations and the nomograms and the design charts. What is the required for the manual design point of view? That is to be published from one of the requirements of the IRC side. Like special publications we have, but design aids that is not sufficient as per my point of view.
What you said is correct, sir. We don't have any publication relating to design aid to IRC 112 or more drawings.
Yes, sir.
So we have to raise it in IRC meetings likely to be held in the next month. Somewhere in North India, I don't know precisely. So I can convey this message, or I can discuss it in the IRC annual meeting, so that it will be taken to the committee.
One more point I would like to highlight, sir. Here, you rightly explained the angle of this queue at the starting of the presentation. Most of the practical engineers I have seen that there is a misconception or the misunderstanding of the IRC 5 clause regarding the skew angle. Understanding the skew angle based upon the IRC 5 is not a difficult one. But most of the engineers, what I recently faced in one of the design of the bridge also, regarding the calculation of this skew. I calculated the skew angle correctly based upon the topographical drawings, but all of the sudden, after the approval of all the roof checking and all that also, during the commencement stage, the department has raised some queries regarding the skew angle. The main reason behind this is they didn't have the proper understanding of the skew angle. At this juncture, I would like to have some detailed, some minor explanation regarding the skew angle. The skew angle
we have one. I brought one slide for that.
Yes, sir. That's clear, sir.
Yeah, skew angle. I have given it to Sai Ram. If we can share it to me, I can explain it, or you can see in the just 5 slides having emergency. I kept them aside to take them in emergency. If you can share now, I can explain it. You can ask Sairam to share.
Yes, sir.
Fine.
Sharing, sir.
Yeah, one more question there regarding this, sir. The most standard drawings are available for the skew angle of up to 45 degrees, sir.
Yes.
Beyond 45 degrees, can we provide a bridge with a skew alignment, say for 60 degrees or 50 degrees, something like that? Suppose
The
we
problem
design
is with that when the skew angle exceeds 45 degrees, the length of the bridge structure shall be increased.
Yeah, that's
For
one reason.
for each running meter, we are supposed to pay 10 lakhs. If you go on increasing the length of the bridge, if it is 80 degrees also, you construct a screw bridge with 80 degrees screw, that is not economical. Instead, we can modify the approaches. You fix the structure at 45 degrees screw and modify the connecting approaches so that it will be economical.
Yeah, that is one aspect, sir. What I am asking is, suppose if I had designed for the skew angle of say 50 degrees, based upon the not depending upon the most standard drawings, I designed with a skew angle of 50 degrees for the superstructure and also for the substructure. Is it
You can
permissible?
adapt. Yes, acceptable.
Yeah, acceptable. Regarding the score point of view, also, sir.
Are there any limitations as per IRC regarding skew angles to be provided?
Pardon,
Limit.
Suresh?
Suresh, the limit, the maximum limit that is standard drawings available are for 45 degrees too.
But
there is no hard and fast rule that we should not adapt more than 45 degrees too.
Even
We
for
can
45,
adapt.
there are some
Yeah,
limited.
beyond 45. We have to redesign. We have to do our design and we can adapt it, but it becomes uneconomical.
Yes, it will be uneconomical.
As the length of the bridge is increased, automatically it will be uneconomical.
Yeah.
So if you are having sufficient money and if you want particularly, my opinion is provide 45 degrees, provide the approaches suiting the bridge with 45 degrees.
Yeah, limiting to 45 degrees you are suggesting, sir.
Yeah.
By adjusting the alignment of the
approaches on both sides may be realigned.
Yes, sir. The alignment of the approaches should be aligned to the 45 degrees maximum speed, what you are saying.
Yes, the difference is you need to provide a straight length of 15 meters after the bridge and 15 meters level portion after the bridge. Once if that length is available, you can start a curve immediately after 15 meters. Some people say when you are constructing bridges and curves itself, where is the need to have even that 15 meters all? So it
Yes,
is, in quote, it is specified as you provide 15 meters level and straight portion in order to have a proper side distance such that the vehicles shall not collide. You can provide a curved bridge. You can provide a curved bridge and you can continue curved approaches, no problem. Provided there shall be sufficient stopping side distance.
Yeah, the 15 meter criteria is also based on SSD, sir.
Yes.
Yes, and one more thing is, suppose we are crossing more than 45 degrees, the torsional moments what we are getting, the formats may be a problem, sir. That is the need of the study to be done based upon the higher skew angles. The purpose of the skew is to minimize the formation of the score holes and also to minimize the score depths that is taking place and also to have the smooth alignment of the supporting abutments or the piers that is in parallel with the flow direction. That is the purpose of the skew angle.
Yes.
And once we are going with the higher skew, the formation of the eddies or the vortices, that is what we are expecting. That may be requires a special study and the understanding of the flow directions and the formation of the eddies. that may be a critical one, sir, issue. And besides the torsion moments that is in the skew deck design part of is considered. Yeah,
Definitely,
generally the length
that
will
may
be
be the
increased.
reason. That may be the reason to curtail the skew angle to 45 degrees.
Yes, sir. The length becomes L secant theta. That is the
Yes,
one of
yes.
the
It
reasons.
must be multiplied by secant theta means more length.
Yes, sir. Yes, sir. L secant theta is the total skew length. That will be the 1 minus secant theta is the initial length that is to be incurred by the budget expenditure, which is the initial cost of the project, sir.
So each meter costs 10 lakhs means we are saving 10 lakhs if you reduce the length.
Yes, sir. Yes, sir.
So
Thank you, sir.
generally we go for up to 45 degrees in railways or in R&B department. So both are habituated to construction of bridges by railways or R&B department. When compared to other departments, we are having more flexibility and experience in construction of bridges. So that's why I'm telling with my experience not to fill the red earth as gravel under the approach slab to prevent settlement on free hand side. So some people question me, who are you to say that? Who are you to say that bold statement? It is my experience. I say I adapted, I proved it, and my approach slabs did not settle for the past 20 years. We take the case of Cherala RBB where we have all sandy soils in foundation and everything. Even formation was done with the sand, supported with gravel and filter media adjoining the retaining walls. There also we use sand. The settlement is zero in approach slab. But even in national highways, at some locations on either side of the bridge, the approach slabs are settled by few millimeters because of this settlement of fill material under the approach slab.
One more thing, sir, regarding the most of the soils what we are treating as a gravels that comes under the classification of GC soils. That is a clay gravels with the predominance of the clay. Sometimes that it even will not meet the 5 requirement of IRC 78 also of not less than 30 degrees.
The gravel what we are adopting is not at all a gravel as per the definition.
Yes, sir.
The gradation do not satisfy it. The plasticity index shall be more than 6.
Yes,
the liquid limit shall be more than 25.
Hey.
So we are considering it as gravel because of not knowing the properties of gravel clearly. The definition of gravel is different.
Yes, sir.
But we are taking this red earth as gravel. Unknowingly, you can say without sufficient knowledge on gravel.
And also regarding the quality control testing point of view, also we are not stringent on meeting the requirements. Also, that is one of the issues.
It is not even suitable for embankment formation. Also, in some cases, they become slushy, and settlements generally takes place in gravelly soils on first rains.
Yes, sir.
So they must be exposed to rain for one season before they are blacktop. It is my personal opinion.
Yes, sir. We have discussed that point also, no, sir. Yesterday we have discussed regarding that Atal project also, bridge project.
So most of the new roads which are giving cracks are mainly due to insufficiency in the properties of material used for subgrade.
Yes, sir.
There is question from Krishna. Is bridge generally designed for lifespan of 100 years?
Yes, every bridge is supposed to last for 100 years.
Suresh?
One question. Yes, sir.
Yes.
సురేష్ ఇప్పుడు కంటిన్యూస్ ఫ్లో ఆఫ్ వాటర్ త్రూ అవుట్ ద ఇయర్ ఉండేటువంటి రివర్స్ కానీ స్ట్రీమ్స్ లో కానీ మనం బ్రిడ్జ్ కన్స్ట్రక్షన్ టేకప్ చేయాలంటే వాట్ ఆర్ ద మెజర్స్ టు బి టేకన్ అండ్ హౌ టు డైవర్ట్ ద ఫ్లో ఆఫ్ వాటర్?
So if the width of the stream is say 400 meters. Okay. So I will tell you. If the width of the stream is say 400 meters, you are constructing a bridge of 400 meters. You form a bund for 200 meters and allow the water in the other half of the 200 meters, increasing the velocity of flow. So in the bund formed, you can place your well curve and do your concrete and sink the well to the required level. After completion of all foundations in this 200 meters and taken up to the top of a well cap, we remove this bund, allow water to this side and form a bund on the other side. So we provide a bund to a height of more than 0.5 meters above the existing water level and fill it to half it. The velocity will be doubled and we can keep our well cutting edge over this bund and sink it. That is the only way we can do in perennial areas where we do have water flowing throughout the year, but the depth will be drastically reduced in summer season. It is not much difficult to form the bunds.
Yes, sir. One question from Rajshekhar regarding the backfilling of slab culvert foundation trench. Shall we use the gravel as backfill or annual filling with concrete?
The filling with concrete arises only for foundations in hard rock or soft rock. Because while excavating the foundations in hard rock, we adopt blasting. Even though we adopt controlled blasting, the measurement shall be a bit higher than the required values. If the width of the footing is 4.0 meters, it may go up to 4.5 meters. We cannot lay the footing for 4.5 meter width. We provide footing with anchorage arrangement in hard rock as per design, and the gap between the footing and rock shall not be filled with the inferior material. So we fill with VCC M15 concrete as annular fill material between concrete and hard rock. So it is needed or it is to be discussed in case of hard rocks only. In all other cases, we can fill with any material obtained from foundation. Right? Any more clarification required for it?
Yes, sir. Haribabu garu, real Haribabu Adinayadu garu stated that the elastic modulus of soil is an important parameter to calculate the theoretical settlement. The liquid and plastic limit of soil is also important. He mentioned that, sir. And one more thing also, he mentioned that bridges are designed for 50 years. All the bridges have to be periodically checked for deflection and settlement.
The inspection of bridges shall be done twice in every year after construction. One inspection before the monsoon, one inspection after the monsoon. It is just like health checkup. You have to check the health of the bridge structure 2 times in a year. And all bridges are designed for a lifespan of 100 years, to the best of my knowledge. If there is any specific mention that this type of structure shall be designed for a lifespan of 50 years, I do not know. I have to contact some more knowledgeable person and I can clarify it. To the best of my knowledge, all bridges are designed for a lifespan of 100 years.
Mr. Gambi Sridhar sir, he stated, he asked that invariably many approach slabs are settling due to settlement. What is the solution?
Yeah, I already told you, fill it with stone dust in thin layers, compact with vibrator or a plate vibrator is available for compacting slab concrete. You can use that plate vibrator. Please, let me complete, please. You can fill in thin layers of stone dust, compact with plate vibrator or hand rammers, and lay your approach slab. There will not be any settlement based on my experience. Even you can use sand provided it is confined.
Yes,
Okay?
sir. In my experience, sir, the major problem is execution of this fill material under the approach slab, sir. In the
Yeah.
hurry, they will fill in the thick layers of, and they will do the improper compaction due to this, that reasons. Just in my observations, sir.
For
Most
sandy
of the
soils,
approach slabs are settling due
and
to the improper execution of fill material
okay,
compaction beneath the approach slab.
in certain things, we are not supposed to compromise. This is one item where we should not compromise. In sand, we don't require any compaction. If you fill it with water, it achieves maximum density. There is no problem of compaction. Similarly, in case of stone dust obtained from crushers, need not be compacted. It is self-compacting and it is cohesionless. And the settlement in cohesionless soils is zero almost. So I advise you to provide cohesionless soil under approach slab as filling material behind abutment and upon approach slab. Right?
Right, sir. Questions are completed, sir. Just I will conclude this webinar with my vote of thanks. Thanks
Okay.
to our Center's chairman, Engineer Balan Sundara Garu, for his initiation and energetic support in this webinar organization. Our sincere thanks to Dr. Kakinada Garu behind this webinar in his support arranging such a experienced and wonderful speaker. Our special thanks to Suresh Babu Garu, today's speaker Suresh Babu Garu, Deputy Superintending Engineer R&D Circle Nellore, for his wonderful lecture. Thanks to our all ACCA members, participants, student friends.
One thing I want to ask you, please
Yes,
obtain
sir.
the feedback. Please obtain the feedback from the participants.
Sorry, sir.
Feedback. Opinion.
Yes, sir. Feedback link you're not providing, sir.
Okay, no problem. They can send it in chat box or they can send it in WhatsApp. If you can give a number.
Yes, sir.
And they can give
Yes,
their
sir,
opinion. It is
yes, sir,
satisfactory, unsatisfactory.
Yes, sir. Some posts are there, sir. MB Sridhar, excellent presentation, nice experience, sir. Rajshekar posted that. Thank you very much.
Okay.
Some charts are there, sir. Actually.
If the response is good, we shall
Good,
continue
sir. Good,
for
sir.
well foundation.
Yes, sir. Yes, sir. Very good response, sir. Positive
So
response, sir.
we can have another 1 hour lecture on well foundations.
Yes, sir. Yes, sir.
So that we can have a clear picture. We can give a clear picture to the final year engineering graduate students.
Yes, sir. So many. Just I am receiving some more feedback, sir. Nice presentation. To also very.
If you can spare 1 more hour for me at
Yes,
any
sir.
time, I will give you the balance lecture completed.
It is very elaborative and very detailed, sir. We expect at least 2-3 more lectures from you, sir.
Yeah, actually, I skipped some slides in between these slides. Usually, I require 5 hours to complete this 104 slide presentation.
Yes, sir. That's what, sir.
So, depending on the time, I will cut short the slides and remove the materials are removed from the slide. The slides of material are removed, and I continue to complete it early.
Definitely, we'll have 2-3 more lectures, sir.
Okay, thank you very much, sir. Balan Sundarrao Garu. I'm very happy for your encouragement. Even though you are related to buildings, you accepted me to deliver a lecture on bridges.
No, sir. I design bridges also, sir.
Very good, sir.
Sir.
Mostly, I'm a construction engineer. I'm not well versed with designs.
Sir.
Okay, we will definitely have 1 more lecture if time permits.
Yeah, definitely, sir. We'll have, sir.
Thank you all. Thank you.
Sir, I have one request, sir.
Tell me.
Sir, can we upload these videos into YouTube so that it will be useful for many people?
Yes, sir.
No
Yes, sir.
problem.
We have YouTube channel, sir. We are recording the session, sir.
Definitely, you can.
You
You
can
can
search in
upload in YouTube.
ACCA Kakinada Center, sir. You can search in YouTube ACCA Kakinada Center. You will get all our center webinar videos, sir.
Every
That will be
month,
definitely
Thank you,
useful to young engineers.
every month we are conducting webinars, sir. All webinars are available in ACCA Kakinada YouTube channel.
Okay, that will be a good job, sir.
Yes, sir.
Thank you, sir. Sundar sir, shall I conclude the session, sir?
Yes, sir. Yes, sir. Please.
Yes, sir. Thank you, sir. Thank you, Suresh Babu garu. Concluding the session, sir. Thank you.
I am very happy to be with you for these 2 hours. Thank you very much. Wish you a happy
Thank you,
life.
sir. Thank you.
Okay, bye.
Thank you, sir. Bye.